All right, a very good morning to each of you. We are excited because we're going to be learning about multiplying and dividing rational expressions. Remember, a rational means it's a fraction. So we're multiplying and dividing fractions. Hopefully you remember your um, properties of doing that. Some of you may remember, some of you not, but we'll go over it together. So first one I picked was on the first part of the worksheet. I expect for you guys to do the warm-ups yourself, and you can check your answers as you work through those. But I'm going to go through number 4 on multiplying. So when you're multiplying fractions, the first thing you always want to do is factor, right? So step 1 is to factor. And when you factor, there's a couple different kinds. There might be just a GCF. You might just have to factor, or you might have to do both. So depending on the problem, you may have to do one, you may have to do the other, or you may have to do both. So I'm going to first focus on this guy up here and see what I have to do. Two terms. So there's two terms. It's either going to be a GCF or a difference of perfect squares. And so first I always check for a GCF. So I want to look for a number that I could divide both of those two by. And it looks like I can divide both by 4. And if you notice, they both also have an x, and the most amount of x's I can take out is just 1, so I'm going to have a 4x. So if I had 4x squared, and I took out a 4 and an x, I'm left with an x. If I had a 4x over here, and I took out the 4x, I have to replace it with something, so I put a -1. So that was just a GCF up there. Next one, I have 3 terms, so I'm probably going to factor. So let's remember how we factor. Well, it multiplies to give you -3 and adds to give you +2. Okay, hang on 1 second. And the only numbers that multiply to give you -3 are 2 and 1. One of them has to be 3 and 1. Whoops. Thanks for catching that. 3 and 1. And since the 2 has to be positive when I add it, that means the smaller number has to be negative. So that is going to factor into x plus 3 and x minus 1. Multiply by, let's factor the second fraction. So I have, again, 3 terms here, so I'm going to factor that. What multiplies to give me -6 and adds to give me a +1? Well, our options are 6 times 2, and that won't give me a 1, or 6 times 1, or 3 times 2. And that option is the one that will give me a 1. How do I get it to be a +1? Is to make these two negative. So now my two factors are x plus 3 and x minus 2 over one term 4x, so that stays. Alright, so we've factored everything either by using a GCF or by just normal factoring. Once we have done all of our factoring, the second step is to simplify. And by simplify, I mean get rid of common factors. Right? Get rid of. So that means divide them out, right? If I have 2 divided by 2, that gives me a 1. So if I have 2x divided by 2x, that also gives me a 1. If I have 2x plus 4 divided by 2x plus 4, that also gives me 1. So when I say simplify, I mean whatever common factors you have, one in the numerator, one in the denominator, we're allowed to get rid of because they simplify to become a 1. So when we do this, we can simplify straight up and down. So we can simplify anything within that fraction. We can simplify anything with that fraction, or we can go diagonally and simplify anything that way or that way. But let's make it clear that in order to simplify, it has to be the exact same factor. I can't take part of a factor. I have to take the entire factor, meaning I can't just take an x if it was x plus 5. I have to take the entire x plus 5. So let's see what can simplify. So I'm going to look at this first one here, this first part of the fraction, 4x, x minus 1, and then over x plus 3 times x minus 1. So if I look at that, I see an x minus 1 and an x minus 1, same factor, so they're gone. That's the only thing they have in common. So then I'm going to go to my second fraction, x plus 3 times x minus 2 over 4x. Nothing in there is the same. So now I'm going to go diagonally. 4x is over here, and a diagonal from that is 4x. Those are the exact same factor, and when I divide them, they become 1. I'm going to look at the other diagonal, so this one over here and this one over here. And I notice that they have the entire factor, x plus 3, so x plus 3 is gone. So I have factored vertically for each fraction, and then diagonally for each fraction. And if I look carefully, all that I'm left with, I know there's a lot going on here, but all that I'm left with is x minus 2. So x minus 2 is my final answer. There's nothing in the denominator, so you could put it over 1, or just leave it x minus 2. So that's the first example, multiplying. So multiplying, you factor first, either with a GCF or normal factoring. Could be both. Once you do that, you simplify. So you look vertically, then you look diagonally and see what factors can get rid of. All right, moving on to the next part, dividing rational expressions. Very, very similar to the first part, except the first step. If you guys remember when we divide fractions, so say we have 1/2 divided by 3/5. Our first step when we're dividing fractions is to keep the first, change division to multiplication, and flip or take the reciprocal of the second. Once we do that, we just multiply across and do that, right? And so it's the same thing here. The first thing we have to do is keep the first, so 3 over 4x minus 8. Keep the first, change division to multiplication, and take the reciprocal or flip the second one. All right, so that's our first step. Everything after this is the exact same. We factor, and then we simplify. So if I look at this first one, 3 can't be factored, so that stays. 4x minus 8 is either going to have a GCF or be able to factor, and because there's no squared term, we can't factor that. So we're going to find a GCF. So between 4 and 8, I can divide by 4. There's no x in both terms, so I cannot take an x out, and I'm left with x minus 2 times. Now I'm going to factor x squared plus x minus 6. I knew I had the x factor because of the squared. Negative 6 goes on top. Whoops, 1 goes on the bottom. And we did this one before. Let's see, it was 3 and 2. 2 is negative. So we have x plus 3 and x minus 2. And the last one, x squared plus 3x, 2 terms. So it looks like maybe a GCF. So I look at x squared and I look at x. They cannot take out a coefficient, so I can't divide by a number, but I can take out one of the x's. So I'm left with x on the outside, x plus 3 on the inside. First thing I'm going to check, can I simplify the first fraction? 3 and 4, nope. Can I simplify the second fraction? And hopefully it said yes. I see x plus 3 and x plus 3, same factor being divided, so that simplifies to become a 1. Now I'm going to go diagonally. Looks like 3 over an x, so I can't simplify there. Let's see if I could go the other way, if they have anything in common. Oh, look at that. I have an x plus x minus 2 up at the top, x minus 2 in the denominator. They divide out to be 1. So what do we have left over in the top that I did not cross out? Looks like just a 3. In the bottom that I did not cross up, a 4 and an x. And if I did my job correctly, that should be my final answer. I should not have to simplify anymore. So the rest of your task is to complete the remaining problems on this worksheet. If you have questions, please ask. Otherwise, submit it and have a fantastic day. Say goodbye.
Bye.